All right, for problem number 3, this is from the 1998 test. It says, let R be the region bounded by the x-axis, the graph of y equals x, and the line x equals 4. I believe this one is no calc, just because I'm seeing the functions are kind of basic. So part A says, find the area of region R. So first, let's graph the region that we're looking at so we can see what's top minus bottom. So square root of x starts at 0, 0 and curves this way. We've got the vertical line x equals 4. And I'm just going to make a note to myself that when x equals 4, y is equal to 2. So we're looking at this region here and bounded by the x-axis as well. So find the area. So top minus bottom is just square root of x minus 0. So the r that we're looking at is square root of x minus 0. And the area is the integral from 0 to 4. Everything should be in terms of x, of square root of x dx. And like I said, we're doing this without a calculator, so let's go ahead and integrate this. So x to the 1/2, when you add 1 to it, you get x to the 3/2 divided by 3/2 or times 2/3. We're evaluating from 0 to 4. So I'm going to pull the 2/3 out here because both terms, well, no, I guess it doesn't matter. I'm putting a 0 in. If we were putting in a non-zero number, I would pull the 2/3 out. But it doesn't matter here because you're going to get 2/3 times 4 to the 3/2. So 4 to the 3/2, remember, that means square root of 4 raised to the third power. So that's 8. So 2/3 times 8 minus 2/3 times 0. You don't have to show that part. I just like doing it so I don't forget about it. So this is 16/3. All right, so that's part A. Part B, find the value of h such that the vertical line x equals h divides the region R into two regions of equal area. So there's some h we can place in here where h makes the area on the left equal to the area on the right. Now, we did just find the entire area was 16/3. And you could either let your integral go from 0 to h or h to 4. It's always best to involve 0 in your calculations. So I'm going to say that I know the integral from 0 to h, wherever that cutoff is, of square root of x minus 0 dx should equal half of the total area. Half of 16/3 is 8/3. So I know that's got to be true. And now I can just integrate to see what this is. So you get the same antiderivative, right? So you're saying 2x to the 3/2 over 3 should equal, from h to 0, should equal 8/3. And then let's plug h into that. So that's 2/3 times h to the 3/2 minus 0 equals 8/3. Let's get rid of that 2/3 by multiplying by 3 over 2. So now it's h to the 3/2 equals 4. So h equals 4 to the 2/3. We raise that to the reciprocal power. This seems familiar. Did we do this in the notes or something together? I don't know. But h is equal to the cube root of 16. And then part C, the vertical line x equals k divides the region R into two regions such that when these two regions are revolved about the x-axis, they generate solids with equal volumes. Find the value of k. So, okay, what do we need to do here? Well, I would kind of tackle this the same way. Let's go ahead and find the whole volume, see what value it is, and then we'll set up an integral that only goes from 0 to k. So how about we do that? So first, let's find the volume. If we generate this shape, we're generating this around the x-axis. We get this kind of dome shape. So this is going to be the disk method, where r is, again, just the square root of x. So the volume of the whole thing, we're going from 0 to 4. Volume of the whole thing would be the integral from 0 to 4 of, I forgot my pi, sorry, pi r squared. Pi times the integral from 0 to 4 of the square root of x squared dx. So this is really just x, right? So pi times, what's the integral of x? X squared over 2, going from 0 to 4. So what's the volume of the whole thing before we cut it in half? it is pi times 16 over 2. So it's 8 pi. So the volume of the whole thing is 8 pi. And then let's set up volume for half. So somewhere in here, we put, it was a vertical line, right? Yeah, we put a vertical line, x equals k. So somewhere we throw in a vertical line that says, now if I only revolve this little section, I'm going to get half of 8 pi. So the integral from 0 to some value k of, with a pi out in front, of square root of x squared dx should equal half of 8 pi, so 4 pi. So let's get that pi out of there. Let's integrate this. So again, this is really the integral of x, so that's going to give me x squared over 2, evaluated from 0 to k, and now it's just equal to 4 because I divided both sides by pi. You can do that since it's an equation. So this becomes k squared over 2 minus 0 equals 4. K squared equals 8. K equals, does it say that k can't be negative? Oh, I know why k can't be negative. It doesn't say that. It does not say that. But remember, the only region we're looking at is this region from x equals 0 to 4. So we don't want to say that k is plus or minus 2 radical 2. K would just be 2 radical 2, or square root of 8. All right. Let's do our next question. This one is calculator allowed. Calc, okay. I put this graph and this equation on your summer work, so I don't know if it looks familiar or not. But just graphing this in the correct window and getting some accurate points is something that we did in pre-calc a lot. So the temperature outside a house during a 24-hour period is given by this function. They've given us a window where f of t is measured in degrees Fahrenheit and t is measured in hours. Sketch the graph of f on the grid below. So they gave you a grid for a reason. You should be accurately plotting the temperature at times 0, 6, 12, 18, and 24. So let's let our calculator do the heavy lifting for us. They've even shown you the window too, right? So a couple of things. Make sure you're in radian mode. Clear out whatever's in your y equals. Type in your equation, 80 minus 10 cosine of pi x over 12. Excuse me. And then let's go to the window. Now, see how they have the window set? It's going from 60. Oh, sorry. The x values are going from 0 to 24. And they're not counting by ones. They're counting by sixes. So I can match that even if I want to. And the y minimum is 60. The maximum is 100, and it's counting by tens. So you can really get it to match if you want. No zoom necessary because you just made all the adjustments and you would just press graph. So that's nice. And then you can either use the table or you could use value to say, okay, so what is x of 0? I can guess that it's 70, but just to be sure, 70. Great. What is, or you on your home screen, you could also be doing what is y1 of 6? 80. What is y1 of 12? 90. I bet this is symmetric, right? Our graph looks symmetric, so I'm going to save time. You could double check these if you want, but I'm going to save time and just plot them symmetrically. Sketch the graph with the correct concavity. Looks good. Okay. That's part A. Part B says, find the average temperature to the nearest degree Fahrenheit between 6 and 14. Now remember, this is a model of temperature. So this is a model of capital F of t. They want us to find F average. This is back from chapter 4. You find an average by finding the integral and dividing it by the time span. So it's like 1 over 14 minus 6, if you want the official formula here, times the integral from 6 to 14 of f of t dt. We're allowed to use a calculator, so we don't have to rack our brains about what is this integral, although this is something that you could integrate with u sub, but do not waste any time doing that. Let's just put this in the calculator and see. So, all right, so let me see here. I already have the equation in my y equals. So on my home screen, this is 1/8, and then math 9 from 6 to 14. And then I'm just going to type in y1 right here, alpha trace y1 dx. So the average temperature is 87.162. And the label on this is degrees Fahrenheit. Does that seem reasonable? Take a look at the graph. Yeah, the temperatures range from 70 to 90. So 87 as an average temperature seems kind of reasonable. All right. What about part C? An air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. So like this chunk of time here. For what values of T was the air conditioner cooling the house? So I should just be finding the intersection, right, of the graph and 78 degrees. So again, I'm going to go to my calculator. I'm going to enter 78 into Y2, hit graph. So yeah, I'm just looking for these intersection points. So second trace intersect. So the first time, now I'm going to write down the full times here because I have a feeling we might need to use the unrounded times. If I look at part D, yeah, we're looking at any time the temperature exceeds 78. So let's write down these full times. We don't want to round them. So this is for times between 5 actually, hold on. I should show the equation. What am I solving here? Because I don't want to just give answers. I'm looking at when is f of t greater than or equal to 78 degrees. So that is when t is between 5.2308694 less than or equal to t, less than or equal to, what's the other intersection point? You've got to get your cursor closer to that side so it finds the other intersection point. So over the hump there. So again, non-rounded, 18.769131. These are rounded values, by the way, but we're just taking them to as much accuracy as we can get from our calculator. All right, so that's all that we have for part C. And then for part D, the cost of cooling the house accumulates at a rate of 5 cents per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. So if the outside temperature is 78 and the air kicks on, you're not charged anything extra, right? But if the temperature is 80 degrees, then I'm going to get charged 2 degrees over what I was times 5 cents. So 10 cents for if the house hits 80 degrees. And then if it sustains that for a long time, 80 degrees for a long time, then it would be 10 cents times however many hours that is, right? So what is the total cost to the nearest cent to cool the house for this 24-hour period? So we know that the house is above 78 on this time span. So I think we need to look at, well, how many total degrees was it over? Because see how it fluctuates a bit? How many degrees total over 78 is it? And then we're going to multiply that by 5 cents. So that would be like 5 cents times the integral of these two times. I think I can get away with this. I'm not going to count off on our tests if you do that. AP test, I don't know. Maybe I can get away with that since I have it written down here, or maybe you should write it all out. And then what were we looking at? We were looking at the equation f of t minus 78 dt, right? Because this would add up how many degrees, how many degrees total, that we are over 78, and then multiplying that by 5 cents. So let's see what that comes out to. All right, so on my home screen, I'm going to say 0.05 times the integral from, write it all out here, 8694 up to 18.769131. Remember, you have f of t in your y1. And then minus 78. You just want to see how far over 78 degrees it is. So to the nearest cent, I'm getting an extra $5.10 as our extra charge for that little time period. Okay. And that's all we had to do for this question. All right. That last question is kind of a weird thing to wrap your brain around, but yeah. Okay. Anyway, sorry. So for number 5, it looks like we're back to probably no calc. And I swear we had this for sure. We had, if we didn't have this exact problem, we had something very close to it in our notes. So see if you can do it now, again, without using those notes. All right. So the shaded region R is bounded by the graph of y equals x squared, the line y equals 4 as shown above. Find the area of R. So the area of R, top minus bottom, is just 4 minus x squared. What are the x bounds of this integral, or where do these two things intersect? At plus or minus 2. That's when x squared equals 4. You wouldn't have to show this. So the area should be the integral from negative 2 to 2 of 4 minus x squared dx. Because it's no calculator, we've got to go ahead and do this number crunching here. So this is going to be 4x minus x cubed over 3, evaluated from negative 2 to 2. That's going to give us, when we plug in 2, we're going to get 8 minus 8 thirds. Minus, when we plug in negative 2, we're going to get negative 8 plus 8 thirds. Now do the rest of this math however you need to. I like to do the like denominators first. So 8 plus 8 is 16. Negative 8 thirds minus 8 thirds is minus 16 thirds. And then 48 thirds minus 16 thirds is 32 thirds. All right, so that's our area. Part B says, find the volume of the solid generated by revolving R about the x-axis. So I always like to sketch what I'm looking at here. So here's my little region that I have. It goes from negative 2 to 2. We're supposed to revolve that around the x-axis. That means that there's going to be some empty space, right? So you're always connecting back to the axis of rotation. So the outer part connects from the line y equals 4 to the horizontal x-axis, which is 0. So the outer radius, if you spin this around, you're going to get this cylinder, and it just has these two funnels kind of cut out of it. Okay, so that out of there. So that's capital R, and then lowercase r is connecting the bottom of the parabola to the x-axis. So the bottom of the parabola is x squared. Any part of the parabola is x squared minus 0. And then volume is pi times the integral from negative 2 to 2 of capital R squared, so 16, minus lowercase r squared, so x squared squared x to the 4th. I don't always simplify those, but for the ones where I'm not using a calculator, I simplify to make life a little bit easier. So this is going to be pi times 16x minus x to the 5th over 5, going from negative 2 to 2. And that is pi times, so when you plug in 2, you get 32 minus 32 over 5, minus, when you plug in negative 2, you get negative 32 plus 32 over 5. 32 plus 32 is 64. Negative 32 over 5 minus another 32 over 5 is minus 64 over 5. Now, 5 times 64 minus 64 leaves me with 4 times 64 over 5, if I just do the like times 5 over 5 thing. And what is that? That is 256 pi over 5. Part C, there exists a number k where k is greater than 4, such that when r is revolved about the line y equals k, so k is above 4 here, the resulting solid has the same volume as the solid in part B. Write, but do not solve, an equation involving the integral expression that could be used to find the value of k. So again, I'm still going to draw a picture because the location of k is important. So we have this little section going on, and this is where 4 is sitting. K is somewhere above 4. So we're just saying, okay, if you were to generate this solid, it's got the same volume as the previous one. So take a look at what this is. So this is K. So your outer portion would connect K back to the parabola, and the inner portion, excuse me, would connect K to 4. So capital R is top minus bottom, so it's K minus x squared. Lowercase r would be K minus 4. And then we need to set up our equation. Excuse me. So volume is equal to pi times the integral. We're still going from -2 to 2. So from -2 to 2 of capital R squared, so K minus x squared, the quantity squared, minus lowercase r squared, K minus 4, quantity squared. You do not need to spend any time squaring those out or doing anything else. Or doing anything else with this. If you follow the directions, it's not V equals. It's that this volume is supposed to equal 256 pi over 5. You don't want to do all that work and then forget to set it equal to the area from, or the volume from part B. All right, I think we have time to get these last, not all of these done, but maybe one or two. Okay, let's take a look at this one from 2001. Let R and S be regions in the first quadrant as shown above. R is the region bounded by the x-axis and the graphs of 2 minus x cubed and tangent x. 2 minus x cubed is on the top here, and tangent x is on the bottom if we're looking at S. S is bounded by those same two graphs. Okay, find the area of R, and then we'll find the area of S. So to find either area for R, well, let's see. So take a look at R first. You could do top minus bottom, or you could do right minus left. I think I'm going to do right minus left because we haven't done a ton of that, and I just want to show you. If I'm going to do right minus left, I need to solve each equation, though, for y. So if it's y equals 2 minus x cubed, I'm sorry, I need to solve each equation for x to get it in terms of y. I would add x cubed to the left, subtract y over to the right, cube root, which does not involve a plus or minus. Okay, so here's this one. So this is cube root of 2 minus y. And then what about the other one? It's y equals tangent x. So go back into your pre-calc days. How do you get rid of a tangent? You inverse tangent. So the inverse tangent of y is equal to x. So that would be my left. So right minus left. And then I need the y value where these two graphs intersect. So let me go over to my graphing calculator. Now S is going to be top minus bottom. So I'm going to find this entire ordered pair and write down the 2 points. All right, so let's get this thing graphed first of all. I want to graph the original equation. So 2 minus x to the third and tangent x. And then what about the window? It's probably not very big. It's definitely first quadrant. So 0. Let's just go like 0 to 2, count by ones. And then 0 to 2 and count by ones. And just see what happens. Because when you plug in 0, you're going to get 2 for the x cubed graph, right? So that seems reasonable. But count by ones. Let's just graph. Okay, yeah, so that's good. So I want to find this point of intersection. So second, trace, intersect. So when they give you a graph, I should just say this. When they give you a graph, use it to try to figure out what your window should be. You don't always have to zoom. If you zoom fit on this one, you're probably going to get a pretty zoomed out window because tangent repeats. Let's write down all of these decimals without rounding them. So the x coordinate, and put them in the right spot, is point, let's call this A. A equals 0.902.155. And I'm just going to call this one B. B is 1.2657507. All right, so back to R. Because I'm doing right minus left, the area for R is going to range from 0 to b, which was the y value. And right minus left is going to be the cube root of 2 minus y minus the inverse tangent of y dy. If you do top minus bottom, then you're going integral from 0 to a of tangent x minus 0, and then integral from a to whatever this point is. You'd have to find that 0 there. I guess it's just cube root of 2 probably, but anyway, find that 0, and then you'd be on the cubic graph. Okay, so what is this going to be? So math 9, 0 to 1.2657507. And what was I typing in? Remember, cube root, yes, it's in the math menu, but just raise something to the, just raise it to the 1/3 power. We've done that forever. On paper, we often forget about it in our calculator. Minus its inverse tangent, so second tangent. And remember, we're using x just instead of y because the algebra, the antiderivatives, don't rely upon the variable itself. So this is about 0.729. All right. Now the next part says find the area of S. So area of S, when I look at S, there is a top minus bottom thing happening, and it's happening all the way across, so I don't have to set up two different integrals. So I'm going back to the functions. Everything's going to be in terms of x. All right, so this will be the integral from 0 to a, because I want the x values, of, on this one, 2 minus x cubed is on top, and regular tangent x is on the bottom, and then dx. Make sure, again, that you're in radian mode. Math 9, 0, up to, I got to see what this is, 0.902155. And then the functions were 2 minus x to the third minus tangent x dx. So that is 1.161 approximately. All right, and then what does part C ask us to do? Find the volume of the solid generated when S is revolved about the x-axis. So I like to re-sketch what I have so I know what I'm looking at. S does go through 0, 0, right? Because tangent of 0 is 0. You can confirm that on your calculator if you need to. So when you sketch this, it's good to know, because you're revolving around the x-axis, that it does connect there. So, your sketch doesn't have to be anything crazy, but something like that. And then we're going around the x-axis, so we would have something like this. But the important part is that you have an outer radius and an inner. So this is washer method. Capital R is the cubic that's on top, 2 minus x cubed minus 0 technically. And lowercase r is the tangent x minus 0. And volume is pi times the integral from 0 to a. Let me double check that. Yes. Of capital R squared, so 2 minus x cubed, that quantity squared, minus lowercase r, tangent x squared. You could write tangent squared x if you want to, dx. I like writing it this way because I'm going to type this into my calculator. So now let's see. This is 0 to a, so because I'm lazy and I don't want to type it in again, I'm just going to delete my other stuff in here, but keep the decimal that I had. Okay, so this was the quantity 2 minus x to the third squared minus tangent x quantity squared. So I'm getting, oops, I forgot the pi, times pi. So I'm getting 8.332. Forgetting pi is easy to do for me anyway, so just be careful. I forget pi all the time, and I realize I made a mistake somewhere. And when you're doing these problems, you're getting points for the correct bounds, you're getting points for the integrand. You get 1 point for the answer, but most of the points come from the setup and stuff. So you don't want to forget pi, but it's not losing all your points. Okay, I'm going to stop there, and then the last video will have these last couple of problems.